Hello everyone. Today we're going to be talking about integers. Integers. That's one of those words that people throw out and people don't even know what it means. Integers basically are whole numbers. Where real numbers are fractions, decimals, and anything else, whole numbers, decimals, and whole numbers. Because if you take out, in other words, when you're drawing a number line, and this is 0, this is -1, and this is +1. These are the integers because they're whole numbers. In between the whole numbers, you have the real numbers, which is 1/2, 3/4, 1/4, and then 3/8, and then you got all these little decimals and fractions and an infinite amount of decimals and fractions between 0 and 1. Same thing here. -1/2, -3/4, -1/4. And you've got between those an infinite amount of fractions and decimals in between the integers of 0 and -1. So, first of all, integers are basically whole numbers. That can mean positive and negative. Real numbers are fractions, decimals in between the integers. That's the best way to explain what the difference between integers and real numbers are. Real numbers do include the integers, but the integers do not include real numbers. All right? So, real numbers are these little dots in between the integers that are highlighted. Okay? So that's what integers are. Now, you've been studying integers when you learned how to add, subtract, multiply, and divide whole numbers. That was integers, except we did not include the negatives at that time. Now, what does positive and negative tell us in math and science? Positive and negative tells us one thing in math and science. It tells us direction. Okay, that's what it tells us. Don't let anybody tell you different. When we graph a line, a positive slope means left to right up. A negative slope means left to right down. In accounting, a negative amount of dollars means you're in debt. A positive amount of dollars means you're to the good. All right? A positive amount of dollars means you got money. Negative means you got debt. Debt, debt. However you want to call it. All right. What about football? Football, positive, means yards gained, meaning past the line of scrimmage. What does minus mean? It means behind the line of scrimmage. So, whenever you see a positive and negative in real life or in academia, it's going to give you, somewhere in the sentence, it's going to give you a direction. Going up, going down. Below the balance of 0, above the balance of 0. Behind the line of scrimmage, past the line of scrimmage. Okay? So, I guess that's called a preposition. I don't know, I'm not an English person, but I believe that's called a preposition, meaning that it's showing you direction. So, what is absolute value? Absolute value is equal to the distance from that number to 0. So the absolute value of -5 is 5. When you go from Greenville to Spartanburg, or Anderson to Greenville, let's say Greenville to Spartanburg, is there a road sign that says Spartanburg -5 miles or Greenville -10 miles? No, because distance is neither positive or negative, because positive and negative tell you direction. Absolute value tells you distance. So therefore, if I give you the distance, if I have -1 right here, a +1, that tells me it's to the right of 0. If I have a -1, that tells me it's to the left of 0. But the distance between 0 and 1 is 1. The distance between 0 and -1 is 1. So I would highly suggest that you learn that, well, no, I don't want to do that. Let's highlight. This is very important. And absolute value gives you the distance. Okay? Now, what are we doing? Well, I like to start off, when I start talking about integers, I like to start off by looking at the number line. Okay? Now, I use dollar amounts when I'm teaching the operations of addition and subtraction. I like to tell students to use dollars in their head, but you can also use traveling on the number line but I don't use traveling, I use dollars. But for instance, if I tell you, here's the number line with positives and negatives, this is reals right here, and this is integers. Integers are whole numbers. These are integers. These are integers. These are integers. Okay? So the only one that has real numbers is the 0, 1/8, 1/4, blah, 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 up to 1. That's the real numbers. Because that's got all your fractions and decimals. And there's an infinite amount of fractions and decimals between these marks. So integers are what we're going to be talking about. Now, operations with integers, I'm going to do multiplication and division like I did fractions. I'm going to do those two first because those are real simple. When you multiply or divide integers, all you have to remember is like signs are positive, unlike signs are negative. I like to tell students to think of jumper cables. When you have jumper cables, and those of you that don't know what jumper cables are, they're cables that if you got a dead battery, if you leave the lights on in the car, you take a pair of jumper cables. Those are little clamps on the end. And the jumper cables are, well, I can't draw there. They have a clamp on the end of them. And most of y'all have seen them. One's red and one's black. Black goes on the negative post of your battery. Okay? And the red goes on the positive post of your battery. So these are what you call like signs. Positive and positive, negative and negative. If you put the positive on the positive and the negative on the negative, everything will be fine and you'll crank your car. And if if your headlights were left on, don't leave your headlights on. Okay? What if you cross them? Well, if you cross a negative to a positive and a negative to a positive, you're going to melt the cables and the battery and probably your alternator. It's not good. Okay? So negative would be not good. Unlike signs is crossing your batteries. Okay, you don't want that. Like signs, everything's good. So kind of remember that, especially if you know what jumper cables are. That'll help you to remember like signs are positive, unlike are negative. And that's all there is to it. So if I take -6 divided by -3, I have like signs. And I'm going to color them green. Green means good. So that means I got a +2. Now you don't have to write +2 because if there is a 2 as an answer, it's assumed that it's a positive because you don't put you don't put a positive in front of every single number that you write. If I want to multiply -6 times -4, again, I have like signs. Like signs are good. So that means positive. And you don't have to write the positive, so you just write 24. So that's how you do like signs. Unlike signs is like crossing your battery cable. And that's not good. So -8 divided by +4, and this is not good. Negative, and you got a positive right there, not good. So your answer is going to be not good, which is -2. -16 times +2. Again, you have unlike signs, so that's not good. So your answer is going to be -32. Oops, I don't like to use red unless I'm trying to, hold on a second. Equals -32. So as you can see, when you have negative and a positive and you're multiplying or dividing, that's not going to come out good. So you have to say, I'm going to write this in red right here, negative and a positive. The reason I'm making them red is they're unlike. Okay? When you have unlike signs and you multiply or divide, and I don't care if it's algebra, I don't care if it's trig, I don't care if it's math, I don't care if it's calculus. If you multiply two like signs, you're going to get a positive. If you multiply two unlike signs, you're going to get a negative. Okay? Now, what if you have more than, well, if you have more than one or two? Same thing. So let's go to another example. -3 times +2 times -6 times -1. Go left to right. Okay, this is negative, this is positive. So that's going to give me a -6 times -6 times -1. Now the reason I'm doing this in red is I'm showing you that the negative and the positive make this -6. Now I'm going to multiply -6, and I'm going to take the highlighter, and I'm going to highlight, sorry, I thought I had green. There we go. That's like signs, so that 6 times 6 is going to become a +6 because I've got like signs, and then -1, and here I've got a negative and a positive, So I've got unlike signs, so my final answer is going to be negative 6. Same thing with exponents. Let's go ahead and we're going to study about exponents here in the near future. If I have a negative 3 and I raise that to an even exponent, like a 2, that would be negative 3 times negative 3. That will always give me an even exponent, will always give me a positive number because the even exponents make the signs what? Like. If I have a negative, if I have an exponent that's odd, like a 3, then that means negative 3 times negative 3 times negative 3. Negative 3 times negative 3, we'll go ahead and highlight those as like. That gives us a positive 3 times a negative 3, and that, I'm sorry, negative 9, sorry. Focusing on the signs. And then that gives us a negative and a positive, which means unlike, and then that's 27. So what you need to remember is on adding and not adding, multiplying and dividing, you've got to remember if you multiply or divide, like signs are positive, unlike or negative. And I don't care if you divide, if you're multiplying 2 numbers, if you're multiplying 4 numbers, if you're multiplying with an exponent or an odd exponent, even exponent or an odd exponent, if you write it out, you will see that the like signs are positive and the unlike are negative. And hopefully that will help you with multiplying and dividing signed numbers or signed integers. Now let's talk about adding and subtracting. Now I go a little bit against the grain here when I talk to my students. I tell them to remember 3 rules. 3 rules with adding and subtracting integers. Adding and subtracting integers. And I can't spell today. Integers. The first rule, positive means you have money in your pocket. Two, negative means you owe money to someone. And 3, anytime you have 2 negatives squished together, that means that you're going to change that to a positive. That's the only 3 rules that I tell students to learn when I tell them to add or subtract integers. So let's do some examples. First of all, I'm going to slide this over. Slide this over. And make it a little bit smaller. There we go. And we're going to add a few of these together. How about negative 2 minus 6? Well, the first thing you do is read from left to right. This means you owe $2. This means you owe $2. Owe $6. Now, if you owe your sister $2 and you owe your brother $6, you owe some money. So owe means negative. And how much do you owe both of them? $8. So you owe $8. Let's do another one. Here, you owe $12. Here, you have $6 in your pocket. So if you give that person $6, how much do you still owe them? You still owe them negative $6. I mean, you still owe them $6. All right, let's do another one. 4 minus 7. So you take your red pen. You owe $7. You have 4 in your pocket. So if you have $4 and you owe your sister $7 and she beats you up and takes the $4, how much do you still owe her? You still owe her $3. And why do I use money? Because there's 2 things that are most important to everybody in the world: time and money. And people, when you're dealing with money, it takes a very little amount of time for people to realize they're being shortchanged. Money is very important to people. Time is very important to people. Especially when you get older and you have a job or a career, you start treasuring the time you have. And money is very important because we can't live without it. In our society, we have to have it. So it's very important to us. So if you apply the negative to owing money and you apply the positive to having money, then you will never go wrong when you add or subtract integers. Let's do another one. -6 minus a -4. And we'll take our highlighter. We've got to highlight a different color this time. That burnt orange says we got 2 negatives together. So the first thing you're going to do is you're going to rewrite it. -6 means I owe, and +4 means I have. If you owe somebody $6 and you have 4 in your pocket, and they beat you up and take your $4, you still owe them $2. And you can do this all day long, no matter what. Now, will they give you some in parentheses and give you all these? You just got to realize that they're just trying to confuse you. Let me give you an example. Sometimes they write stuff like this. -3 minus a -4 plus a -3. All right, they give you something like that. The first thing you're going to do is you're going to rewrite it because they've got a bunch of junk in there that you don't need. Okay? First of all, you're going to rewrite this as -3. Then you're going to rewrite, take my highlighter out, that's going to be rewritten as a +4. And then this over here, you don't really need to do anything. Now you can rewrite this as, you could rewrite -3 plus 4 minus 3. Now let's see what happens. Here you owe $3. You have $4 and you owe $3. Now, I don't care which order you do it, because you're going to come out. Let me ask you a question. If you owe $3 to one person and you owe $3 to another person, and they both beat you up and take your $4, how much do you still owe them? Because you're still going to owe, because the debt is greater than the income. You know, champagne taste on a beer budget. Your debt is more than your income. So your answer, I don't care which way you do it, your answer is going to be negative because your debt is more than your income. So you owe somebody $3, you have $4 in your pocket, you still owe $1. You owe somebody $1, you owe somebody $3, you owe $4. I'm sorry, I messed that up. I messed that up. Hold on. I found it before you did. Hold on a second. You owe $3. You have $4. That means you have $1 in your pocket. So let's go do that first. So you owe $3. You have $1 in your pocket. I mean, $5 in your pocket, $4 in your pocket. So you pay this person, and that leaves you with $1 in your pocket. You owe another person $3. So if they beat you up and take your $1 away from you, you still owe them $2. Now, you could have easily done this. You owe somebody $3 and you owe somebody else $3. So technically, you owe them $6. You owe two people a total of $6. You have $4 in your pocket. If you owe two people $6 and you give them $4, and what is the outcome of that transaction? You still owe $2. So either way you do it, you're going to get the same answer. It doesn't matter how you do it. It doesn't matter how it's written. If you follow the three rules, if you follow 1, have is positive, 2, owe is negative, and 3, whenever you have two negatives together, you change that to a positive. If you follow those three rules, you should not have any problem with subtraction or addition. So let's try another one. Let's try another one, and let's make it a long one. Let's go with -3, and I'm going to write in colors, plus 4 minus 6 minus 2 plus a -8. Well, first of all, everything is good except for this plus and negative. You don't need that. So what you do is you take that out and change that to a negative, because that's what you're doing. You're just subtracting. Okay? So let's go through and do it. Now, if you want to add up all your debts, you know, end of the month, you take all your debts, and all your debts is equal to $500, and you bring in $1,000, then you got $500, you know, in your pocket. You can do it that way. Let's do it that way. -3, -6, -2, plus 4, minus 8. Oops, that's supposed to be, sorry. That's supposed to be a green, I messed up there. That's supposed to be a minus. -8. There we go. -8 plus 4. Yeah, this is more like a Hubert transaction at the end of the month. Somebody tell me what's greater, the income or the debt? The debt is greater. So your answer, I don't care what you come up with, your answer is going to be in debt. So let's go ahead and figure out how much debt we're in. You owe $3, you owe $6, you owe $2, you owe $8. You owe $21, but let's check it. -9, -9, -11, -8, -$19. So that's -$19 plus $4. So you owe a bunch of people $19. They beat you up and take that $4 away from you. Guess what? You still owe them $15. And that's how you add and subtract integers. Let's try one more, and you do it from home. You pause the video and see if you can do it. I don't know why this thing keeps writing. Let's go with -2 plus 8 minus 6 plus 7 plus 4 minus 13. So I'm going to change all mine to colors. Plus 8, that means I have. Plus 7, that means I have. Plus 4 means I have. So let's add that in our head. 8 plus 7 is 15, and plus 4 is 19. So I have $19. Now take my red out. I owe $2, I owe $6, and I owe $13. So I owe, that's 19 right there, and 21. I owe $21. If I have 19 in my pocket, and I owe 21, then my debt is greater than my income, so my answer is going to be I owe. And then, of course, 21 minus 19 is 3, or 2, sorry. So I owe $2. Now, you could have went across, and you could have done this. You could have done, and I'm just going to write it in black. What's -2? You owe $2. You have $8. Well, if you owe 2 and have 8, you have 6. Minus 6 plus 7 plus 4 minus 13. 6, you have $6. You owe $6. What happens if you owe $6 and have $6? You pay your debt off. Seven plus 4 is 11. Minus 13. You have $11. You owe $13. So if you pay your debt you pay your $11 towards your debt, you still owe $2. So it doesn't matter how you do it. You just need to do it, and you need to remember that if you're dealing with positives and negatives, you just need to remember that you're dealing with money. You owe, you have, and 2 negatives make a positive. And hopefully that will help you with your operations of integers.